All right, so today's super easy day. We're learning how to use our calculator real well. The kinds of questions that we explore today are typically multiple choice questions on the Regents, although we're going to look at them in short answer form. So we're going to graph this. Question number 38, by the way, all the questions that we do today are off a sheet that I've handed out, a worksheet. Question 38, it wants you it gives you a bunch of choices on top, right, of graphs, and then wants you to pick out the appropriate graph. And what I wanted you to do is I want you to use your calculator to figure that out. Now, you don't know how to do these yet, so don't go looking through the graphs trying to figure it out. But what I want to ask you is like, if you were to try and enter this equation into your calculator, right, this one right here, could you do that or no? No, you couldn't. So what do we do, Leslie? In order to enter into our calculator, what's wrong with this? Tell me. Yeah, the y's not by itself, so tell me, how could I get the y by itself? You're amazing, Les. Yep, we're going to minus 4 from both sides, and then you get x squared minus 4 is less than or equal to y. And so now we got to take before we go and use our calculators, okay, we got to take a little side note, because we got to talk about what this symbol right here means in terms of graphs. So let's talk about this for a minute. I drew a bomb and I put this key. This is like a legend if it were for a map, right? You're going to see these symbols presented along the way today, and we got to know what they mean, right? Do you see this stuff over here in the green? This says y is less than or equal to whatever is on this side. Same thing over here. Y is less than whatever's over here. So in terms of graphing, in terms of shading, which you have seen in 9th grade, but you haven't seen for a while, less than, is that upwards or downwards? Good. For these two symbols over here, you're going to be shading down. I'll explain to you what that means in a minute. For the blue symbols, guess which way you're going to be shading? Yeah, because you're going to be shading up because y is greater than the substance over here. Not necessarily reading it backwards. However you want to determine it, what you really have to be able to do is read it so that, do you see the pointy end of this symbol? If the pointy end faces the y, it means y is less than. If the open part of this symbol faces the y, it means y is greater than. Okay? And so this set of symbols means to shade up. Okay? So that's going to be important. The other thing that's going to be important is we got to talk about, let's see, maybe I can highlight it in black. Do you see this business right here? Do you see how there's a line underneath that one? Okay? Back in September, October, when we had to graph these on a number line, what kind of holes were associated with this? Open or closed? So this line underneath means it's going to be a solid line graph. And you can see that on the sheet that I gave out to you, right? You could see some of the graphs have dotted line, dashed lines, and some of them have solid lines. Now this symbol over here does not have a line beneath it. And so guess what kind of graph it's going to give? It's going to give a dashed line. And that comes from the fact that if you were to try and plot points on a number line, this would produce open holes. Okay, so this is like the main important part of today. Let's use our key to examine the graph that I just put forth to you, right? What kind of graph is this? Which way are we shading, up or are we shading down? Very nice, because y is greater than. Yeah, we're going to be shading up. And it's a solid line. Very nice. These are gimmies on your test. Here's what you're going to do. You're going to enter the equation into the graph, just the normal part. Don't worry about this symbol right over here. Okay. Enter that into the graph, and then move all the way over to this screen. Do you see where that dashed line business is? And let's go explore our calculator. Let's see what it does real quickly, right? To change it, you hit the enter button. Now let's see what this thing does. This thing, when you hit the enter button, produces a really big solid line. Let's go back. Hit enter again. What do you think that one does? Shades which way? Of course, it shades up. Let's go back again. Hit enter again. What do you think that thing does? Shades down. And check it out. It's pretty cool, right? It's really cool. Let's go again. Let's go again. Once again, we're just exploring what our calculator does. Okay, the key looking thing does this. Right, does something weird. We're never going to use that ever. This thing does something even more useless. Look. Just traces along some imaginary path. I think the people at Texas Instrument got bored that day and just decided to write that in there. And then finally, we could do it one more time, and we're going to get a nice dotted line looking thing, and I'm sure that does something, but I'm not quite sure what it does, right? Except produce a dotted line. So let's go back. Now let's produce a graph of the image of this equation on our board right here. We're going to be shading upwards, and you want to look in your answers for possible choices that look like this. And which choice looks like that one? Yeah, choice 1. Very nice. Let's do the last question in our lesson today. Last question in our lesson today with regards to this stuff. It's a two-part question, and on your sheet, part A was, okay, you got to graph this. Now, if we were in algebra in 9th grade, okay, and we were learning this, I would say that I would show you how to plug it into your calculator, and then we would spend 2 days graphing them. But that's not needed in this course. You've seen it once already. What you need to do is be able to use your calculator real well and pick out the answers. So part A, we are only going to do on our calculators. Graph it up. So you're going to take it, you enter it into your calculator like I just showed you, right? You don't need to multiply it out. Just enter it in like this because the y is isolated by itself. Which way are we shading, up or are we shading down? We're shading up. Which way? What are we talking about? Solid or dashed lines? Straight up solid lines because that's a greater to that's a greater to or equal sign. So we're shading up. Let's take a look at what this picture is going to look like. Not that one, right? It looks like this. Mad small. That's okay. It's fine like that. Now we're gonna go to part B. Is this coordinate in the solution set? What does it mean to be in the solution set? Is it in the shaded region? Now, period 1 said somebody goes in there, okay, well, what happens if I can just easily count, right? Look, 1 2/3. I can tell you right now the answer is yes. I don't have to do any work. I said that's really awesome, but sometimes they don't make it that easy on you, so go, Arya. Oh, remember what it means to be, this one, I understand what you're saying, the shading. You think the shading's incorrect. Shading upwards, as in like up, towards the top, towards the sky, regardless of which way the parabola is pointed. You understand what I mean?
I don't understand. Because when we did the other problem, it was like 38.
We got to take a side break for a minute because we had a question about shading. I'm just going to draw a series of graphs to show you what I mean by shading, right? A graph could be like this, a U-shaped. And do you know what I mean by shading upwards? I mean shading this way, so that it will produce a graph that looks like this. That's what it means to be shading upwards. Now, if the U happens to be going the other way, right? Let's just suppose the U were placed upwards like this. Then shading upwards would mean like that, and you'd get the shading going on the inside. Do you see what I mean? Yeah, it depends how the parabola is shaped, U-shaped or frown-faced. So now let's go back to this one, right? Let's go back to this graph. So part A was done. C calculator, that's the graph. Is 1 comma 2/3 in the solution set? Troy, Lumberg? Yeah, it is. How could you prove this algebraically? You plug in those numbers. Excellent. That's what we're going to do. And the one thing that I'm going to watch out for when I plug in the numbers is something my boss told me that I have to do a better job of. Whenever you plug numbers in, you should include parentheses where you plug them in. Yeah. No, seriously. Right? And a parenthesis over here. This is good math grammar. And so that's what it looks like. So tell me, is that true? Is negative 41 less than or equal to 2/3? Yes. If it wasn't, we would say no, but it is. So that means that 1 comma 2/3 is in the solution set.